Hello, everyone, and welcome to Passive House Accelerator Live, where we explore how to slash the greenhouse gas emissions from our buildings and make them more resilient to the impacts of climate change. I'm Zach Semke, Director of Passive House Accelerator, and I'm very excited to welcome Bryn Davidson today to present what's next after Passive House. Today's host of the project of the month episode of Passive House Accelerator Live is Shefali Songvi of Datner Architects. And with that, Shefali, please take it away.
Welcome back, everyone. Thanks again for joining us. We're really excited to have Bryn Davidson here. He's the co-founder and lead designer at Lanefab, a Vancouver-based design build firm, working on a variety of different types of projects. The thing that I was most interested in is infill laneway houses, which is just, I guess, a fancier word for infill houses. So, Bryn, I may ask you a question about that later. That blend West Coast modernism with climate-friendly passive house design principles. He also did a TED Talk in 2014, laying out the firm's goals of creating projects that go beyond net zero and have a net positive impact on the climate crisis. So I'm not going to belabor this with that. I think we'll get to why we're all really here. So, Bryn, take it away.
Thanks, Shefali, and it's good to see everybody. I just got a chance to have a quick walkthrough of a house getting built up in upstate New York. It's great to connect with the community across all of North America. Let me share the slides here. Okay. So as Shefali said, I'm Bryn Davidson. I am co-owner. We're a design build company, so we do both the design and the construction. I have a business partner who manages the construction side. So one of the nice things about that is that we can kind of always be tinkering with our systems and be looking at design, the construction, the cost, all those kind of issues on every project. Over the last 16 years, we've done, I don't know, 150, 200 something custom homes, all built beyond code. And for the last 10 years, we've been, I guess I'd say for the first 5 years, we were kind of just making up our own stuff, just kind of winging it. And then eventually we learned about Passive House. And for the last 10 years or so, we've been doing that sort of pretty consistently on a lot of our projects, along with a lot of projects that are CHBA, that's Canadian Home Building Association certified net zero. So we've been tinkering with both of those systems. So I'm going to talk a little bit about one project in particular, not because there's anything, particularly special about that one versus any other one project, but just as using it as a kind of foil to think about the issues that I'm actually increasingly concerned about, which have nothing to do with wall assemblies or U values or anything, but just about our urban issues and how we deal with climate at scale, and all of those kind of things. And so I picked this one in part because it was recently one of the sort of poster childs for the Passive House Canada conference. And there's been a lot of great work happening in all sorts of scales, very different than it was 10 or 15 years ago when we first started. So I'm just going to jump in here. This project is a single family house built over a 2-car garage. This is within this kind of suburban neighborhood. We have the sort of traditional living, dining, kitchen arrangement on the ground floor, with living space with the bedrooms upstairs and a roof deck and balcony. The clients wanted something very kind of clean and modern, and so we tried to create something that was both warm but also kind of had that kind of cleanness that they were looking for. A lot of the typical features we're putting in our projects, in addition to those nice European wood aluminum windows, we've got cedar used throughout the project, and then radiant floor heat, heat pumps for heating and cooling, and reclaimed wood accents that we've used throughout the project. I'll talk a little bit about how some of that came and was worked into it. One of the things I like here is in the middle of winter. This is close to the winter solstice, and you can see that sunlight streaming deep into the floor plate of the house. And I love kind of capturing those moments at different times of the years. in part because we've spent so much time obsessing about shading and about solar gains and all that kind of stuff. But it's nice to see it when it becomes actually part of the living experience. At the back of the house, we have this weird kind of water feature where all the rainwater from the whole house is sort of channeled down through this water feature. And when you enter the front door, you can kind of look through the whole axis of the house and you can see the water streaming down. The clients originally wanted to put a water wheel, like a traditional Korean water wheel on here, but in the end, they decided to just keep it minimal as this kind of rain channel. One of the things that we did here that we are now doing on more of our projects, but this was the first time we did it, is that we actually deconstructed the old house that was on site. So in Vancouver, like many places, there's no bare land. So every time you're building on a site where there's something there previously. So instead of demolishing it, we actually took the house apart and reclaimed all of that structural wood, had it resawn into this nice wire brushed 1x4 to 1x6 to 1x8. And then we were able to reuse that wood on the new house. So we've got all the wood softening, all the wood cladding, the slat walls, everything is actually wood that was reclaimed from the old house that was previously on site before. And this is something that we've been trying to do when we can convince the clients on all of our projects, because it's a really great way to not only capture that carbon, but also to have that kind of narrative continuity of the history of the site from one house to another. And then that warm wood where we've kept it kind of protected under the overhangs does a great job picking up the morning and the evening light and giving a kind of warmth to what's otherwise a fairly, kind of boxy industrial looking building compared to some. So in terms of the design process, I'll go through this pretty quickly because you guys are all familiar with the Passive House design process. We were certifying this under the Passive House Institute in Darmstadt, so under PHI as opposed to FIAS. But a lot of the same ideas apply. This is an east-west property in a kind of suburban neighborhood. In the city, these east-west lots are often a challenge because your south-facing solar gain is blocked by the house to the south. So in this case, we've actually pushed the house as far north as we can, and we've set back that upper roof so that we can create a bit of a roof deck space. And then within that roof deck space, we've created this kind of angle so that when you're up on that roof deck, you're not kind of staring straight down into the neighbor's yard. So we pulled the occupied roof deck part back and then pushed the other part forward. And that gives us this kind of bit of privacy and also blocks that really hot western sun that can become quite problematic. So we have these thin walls on that upper floor and a big overhang blocking that western sun, but of course letting it in the winter. With most of our Passive House projects, we're using a tool called Design PH, which is the plugin for SketchUp. I love this because it's a graphical interface. It's not punching numbers into a spreadsheet, which I don't love. And so with each of our projects, after we've gone through initial concept work, we build this Design PH model. And what you have is you're putting in the thermal envelope and then also the non-thermal shading elements. And then you're running the model, and up here in the corner, you can see we're hitting that 15 kilowatt hours. But you can stretch those windows bigger, smaller. You can do everything. You can do that kind of in real time in a way that is much harder with PHPP. So you can see this house, because of the suburban design rules, the 2-car garage that's required, the smaller upper floor that's required, we have quite a much more articulated envelope than you might see in a lot of passive houses. So the form factor was actually pretty bad. And so we end up having to kind of make up for that in other parts of this project. So this is that upper floor. This is kind of our ideal sort of setup if we've got an ideal setting where we are putting those windows so they're capturing all of that winter sun, but not catching most of the summer sun. So we want ideally to have that sort of that relationship between that overhang and the windows that balances out those two things so that we're not overheating in the summer. So that's all fairly standard stuff. What I'd like to get into next is just talking about not the assemblies themselves, because everybody has their own special sauce. Everybody has their own thing that their thing, 12-part assembly that they love and they want to do. But for us, it's talking about what is that connection between the design team and the build team. And so for us, it's looking at how do we communicate the sequences, everything from, especially the air tightness, through all of those different bits. So for this particular job, we did a double stud assembly, one outer structural wall, one inner service wall, a big cavity that you fill up with insulation. It's pretty simple. The nice thing about it is that most conventional framing trades can just go and do this without a lot of additional training. But in terms of how that lands on site, we have an exterior air barrier, the peel and stick air barrier. We are just penetrating that in a few locations with some beams, and then infilling with hangers. But we wanted to really see how all of that kind of comes together in 3D. So we do a kind of sequential model of looking at how, where are going to be the problem locations with the air barrier, so that we can know in advance what we've got to kind of be really micromanaging, and figuring out those problems in advance. And so we see on site those ideas play out. We've got the peel and stick on our thermal assemblies. We've got cheaper Tyvek on our non-thermal assemblies. We've got our flappy bits, which are, you guys all know those bits of air barrier that you pre-install while you're framing, and you leave some flappy bits so that they can be tucked over with the subsequent work that happens later. And we've done this type of thing a lot, where we're putting an air barrier on and using joists on hangers, as opposed to having joists penetrating through that air barrier and having to seal every single one. And we find this works quite well. So in terms of communication, we did for this job, we did a whole series of these kind of assembly details, which was good for us as designers to figure out what is the actual sequence of how this happens. But also then I can send this PDF to the trades in advance. They can kind of work through the sequencing of how we're going to be doing this. In Vancouver, we have to have rain screen behind all our claddings. We have to have flashings. We got to have all this kind of stuff. So there's quite a somewhat complicated sequence of events going all the way through. And so we're doing that here in 3D with annotation, so the guys on site can really understand how that's happening. And so then they go and they follow that. And we can see we've got these deep window bucks with the sloped subsill, the flappy bits, the membranes, all those things that you guys are familiar with. Another one we did, this is wall to roof connection. So this is what we've done on a lot of our projects, where we're doing this kind of double stud, where we are bringing that air barrier from the outside of the wall over the top plate, tying it into an air barrier on the bottom of the truss, insulating, putting in a hard air barrier, and then dropping below that our service ceiling for our fire sprinklers, our lights, everything else that goes below that. And so we do this on every single one of our projects, whether it's passive house or not, because it works really well. You just put that hard air barrier up, it's vapor retarder, and then you drop all of your servicing below that. Another thing that we tried out on this job for the first time was just looking at a thermal bridge free subsill for our doors. We have these big lift and slide doors. Unlike some passive house assemblies that are insulated on the outside, This double stud approach, you have a cold foundation, which architecturally is nice because you can use the concrete wall as your finish, and you can use that as part of the design of the building. But it does mean you've got a cold concrete there that you don't want to sit your door right on because it's going to be a massive thermal bridge. So one of the things we did here was to develop this subsill structure using Cascadia clips, which are a structural fiberglass standoff. So we're putting these Cascadia clips in, insulating it, creating something that's strong enough to hold a very heavy door, sliding door, but also thermal bridge free. And so these are, again, what we communicated to the guys on site. And then this is what we're doing on site. The Cascadia clips getting bolted onto the wall. They get a ledger board, they get insulated, and we tie in the air barrier, everything in through there. So again, this is a detail that we've done on a number of projects. Sometimes we'll use a fiberglass angle. There's different ways to do it, but this is becoming part of our standard process of designing and then communicating to the site. So just gonna take a glass of water here. I'm sure we could talk for hours about assemblies and U values and HRV strategies and all those kind of things that Passive House nerds, we all love to like dig deeply into those kind of obscure sort of things. But I think part of our work, because we started 16 years ago doing urban infill. In Vancouver, they have a network of alleys throughout the city, and they call them lanes. And so 15 years ago, they allowed an accessory dwelling to be built on the alley or the lane. And they called them laneway houses. And so from when we created the company, the design build company 16 years ago, it was aimed at doing urban infill. And so our work has always been highly focused on doing urban infill. And so one of the things that always struck me as funny about this project that we did on Dalebright, the Dalebright Passive House, was just that it was a single family house. We are, as the crow flies about a couple hundred meters from a rapid transit station, the SkyTrain in Vancouver. And for whatever reason, the city of Burnaby, where this is located, for decades had just kept this strictly a single family zoning. And so when we went in to work with the clients on this project, the only option we had was to put a single family house in, and it just frankly felt really stupid. Like, it's just a phenomenally bad way to be thinking about, tearing down one single family house to replace with one single family house. And even in Vancouver, where you'd think things would be more focused on densification, for years, that's what it's been. And so part of our work, I would like to think, is starting to step outside of that designer builder silo and start to think of how do we use our energy as an advocate to influence this whole ecosystem within which our projects exist. Because it's not just the design, it's not just the construction. And so from our point of view, after doing this, there's a lot of different ways that our projects do impact the climate. And so if we care about climate, then of course we want to look at this full spectrum of things, not just, do we have a gas boiler that's emitting gas or whatever. So there's all of these pieces: transport emissions, legacy emissions, operational, and embodied. And some of these have to do with site selection, which is why I often will talk about project as opposed to building. And the reason I say that is that the project encompasses that early decision around site selection. Where's your money going to land? You're somebody who wants to build a building. You've got a choice about where to put it. You've got a choice about how best to leverage that capital investment to either have a net positive impact on the climate crisis or not. And so the project encompasses site selection, it encompasses the design, it encompasses the construction, all of those things. And I think that we can't, as if you're an architect or you're a designer or engineer, you can't just say, oh, that's outside of my scope of work, because we are all here as advocates pushing the boundaries. And so we've got to break down those silos a little bit. So the operational emissions, I think we're familiar with that. In this case, we certify it as a PHA passive house. But the things that I actually find more interesting is where we start engaging with the cities to do these things at scale. So in the city of Vancouver, we have a 20% density bonus for certified passive house or certified net zero. And that density bonusing system has really allowed a whole community of high performance builders to flourish in the city. And it's had a kind of trickle effect out to the larger industry. We also recently passed a ban on fossil gas in new buildings. We have a fairly clean electrical grid, so there's a big benefit to going to all electric buildings. And even where you have currently dirty grid, that is going to be changing hopefully in the near future. So it still makes sense to electrify, I think, in most cases. So I really think that engaging with policy and your local city planners, all of those kind of things is a critical part of what all of us need to be doing. The next piece is the embodied carbon. There's been a lot of talk about this over the last couple of years. When I did my TEDx talk in 2014, I didn't even really touch on this, which kind of speaks to where the thinking was, at least for me at that point, versus where it is today. Because I think we're realizing now that if you build a passive house and you just build the whole thing out of concrete and spray foam or whatever it is going to be, you're not really getting the benefit that we're hoping for in terms of the climate impact. And so again, we've got dollars to spend. How are we going to best do that in a way that has the most bang for the buck? And so for us, like everybody, it's a learning curve. We've been just recent in the last year, we started measuring this on some of our projects using this beam calculator. There are lots of different ways to do embodied carbon calculations. PH Ribbon, I think there's lots of different calculators. This is the one City of Vancouver is working with. And so we've done it on 2 of our recent net zero projects. And so this first one, this one on the right, is a 4-plex. Our upfront carbon, not the full life cycle, but the upfront carbon, we're at 99 kilograms a meter squared, which is quite good. I'm using a term, in this talk and going forward, I'm starting to talk about this as EC 100 because we're at an embodied carbon up front of less than 100. This other duplex over here, we're at EC 130, which is also pretty good. If we look at the typical new house in Vancouver, they're at about EC 180. So this 4-plex here is about 45% better. So it's a substantial reduction in embodied carbon compared to the status quo. And we would have never known that if we hadn't measured it. So I think this has been sort of one of the new things that we're tinkering with that's interesting. No major rocket science, no major weird products or anything. We put some cellulose in the cavity and we did some fly ash concrete and a few other things, but nothing major. It was just a matter of kind of toning down the concrete and steel and using wood construction and it's a few select substitutions. So we're always trying to figure out what's the most economic and repeatable way to do this, because we don't want to just have the glorious one-off where you have one pilot project that uses all the fancy things that cost a crap ton of money and then it never gets done again because it's not affordable. So we want something that we can repeat. This is another net zero duplex we did recently. We've got reclaimed wood cladding. It's a reclaimed yellow cedar. Doing this modeling, we started to realize how things like the stucco that we were doing versus wood siding, how these things are trade-offs. Concrete pavers on the roof deck versus wood decking, thermally modified wood decking. basements versus no basements. Like all these things, in the same way that all of us here started to wrestle with those issues when we started doing Passive House, you realize Passive House doesn't let you cheat. And so you've got to like really make some hard decisions and really bake things in from the beginning. Um, Having to wrestle with the embodied carbon is a bit eye-opening as well, because it was something we ignored for a long time. And so Dalebright, I think one of the critiques I have of Passive House in some cases is that we sometimes end up chasing a last kilowatt hour, and we end up chasing that by just throwing material, throwing like, we've got a house, there's nowhere else we can't expand up or to the side, so we end up with, in this case, 16 inches of sub-slab foam, which is kind of stupid. It's really overkill. You don't have a big delta T, you don't have anything. But in the PHPP, we need that last little half a kilowatt, and we've got a bad form factor because of the zoning. So this is where we end up with. And so I've been reflecting on the fact that in Passive House, we often have this kind of tension between this kind of desire to reach these very stringent targets, but now balancing that against embodied carbon and cost, trying to figure out, does it still make sense? And so this is something we're working with. The 15 kilowatt hour that allows you to, in theory, heat or cool the house using just the ventilation air. But I don't know about you guys, but I haven't done any Passive Houses where all we did was heat or cool the ventilation air. Maybe you guys are more clever than we are, but we always end up with multiple different systems, and so we've been thinking about that target and its role going forward. Legacy emissions. This is another thing that is not talked about much, but the end of every project, or the start of every project, is the end of something else. And so when we go onto a site, there is something there already. And so our choice of that site and our choice of what we do with that does have an impact on the climate footprint of our project. So if I go onto a site and there's an existing house, we can just smash it up. We separate the metal, we separate the wood gets mulched. It then decomposes back into the atmosphere. The deconstruction that we're doing actually saves a lot of that good old growth wood and allows it to be reused within the new building. This isn't captured in our embodied carbon calculation yet, but going forward, I'm hoping to see end of life calculations for the site in part of the way that we look at the climate footprint of these projects. We are pushing to try and make deconstruction standard. One of our contractors uses a system I'm calling DFAB, where they actually cut the house into panels, pull it apart, ship it off-site, and denail it, take it apart off-site, which means that we can be building on-site much more quickly, as opposed to denailing and deconstructing everything on-site. So I think DFAB is great. We have another local supplier who's actually taking whole houses, picking them up, putting them on a barge and shipping them where they can be reused wholesale, which is awesome. So those parts are part of the climate footprint of your project. And so I'm hoping that that can expand. The other thing that we're looking at is fleet turnover and degassing. Basically, if you've got a project and you're going to put money into a building, try and use it to turn over the fossil fuel fleet of buildings that we already have. With cars, they only last about 15 years. So as the cars get better, you get fleet turnover. But with buildings, they last a lot longer. So I think if you've got a choice between taking your money and dumping it on this pretty greenfield site versus dumping it on that ratty looking old house that's burning fossil fuels, so I can tell you clearly which one of those has a better impact for the climate. So that greenfield site is tempting. It's easy to design. Whatever, that's great. Do a few of those if you want, but try and leverage. So, I've made this little picture here because we think about stripping these gas meters out of each of our projects, and I want to mount them on the wall the way you would like a buck's head. You've hunted that thing and you've found it and you mount it on the wall and you're like, okay, it's gone. That gas connection is gone. So we've had a positive impact through the leverage of our project. The last piece is transport. Again, often ignored by architects and green building folks. This house, right there in the face of this house is a 2-car garage. This is a very car dependent sort of location with very car dependent zoning. And so anytime we look at, okay, how green is that building? That car dependency is absolutely part of that footprint of that project. And if you're calling your house zero emission or zero carbon or zero whatever, and you're not including transportation, you're missing a big piece of that. And so I think that I've always for years been pushing this. I think because we do urban infill, we're always thinking, what could we be doing better in terms of the zoning and housing that we're allowing? And so in my mind, if I look at the walk score of a site, and that walk score is better than the regional average, then we need to be adding more density. If you're in a walkable neighborhood within an area that's not, instead of building one house, it should be 2. Instead of 2, it should be 4. Instead of 4, it should be 40. So this change to zoning is, in my mind, the more interesting piece for a lot of this. And I think that in many aspects, the change with the zoning is more impactful and more important than what we could be doing with the building code. Insulation is great, higher tightness is great, but getting a 4-plex in a walk score 90 neighborhood is awesome. And I think that's that kind of getting out there and being a shit disturber for zoning and not just for buildings is a big part of what all of us need to be doing. And then the last piece, which isn't about emissions, but we're all dealing with, especially now in the last couple of years, which is this resiliency piece. I think we all saw this amazing the survivor, the passive house survivor in California. It's incredible to see that house standing untouched next to the ones that have burned down. And in Vancouver, in Canada right now, half the continent is dealing with fire smoke. We've also been dealing with heat waves. These heat waves are lethal. And so 10 years ago, we were doing passive houses fully naturally cooled, open up the windows at night, close it down during the day. It works great. And for many years that worked, but that doesn't work anymore in this situation where you've got a heat dome, you've got smoke, you got to close things down at the hottest time of the year. And so the old ways of doing things just don't work anymore. And so now as we go forward with our projects, we are doubling down on the shading, roll shades, overhangs. We're putting active cooling in every single project because it's a life safety issue. Like there's so many people that died in our heat dome. It's really incredibly problematic. In Vancouver, we're having to do room by room energy modeling, which I think it sucks because it's sort of more work, but it's important because that west facing upper room on the top floor is very different than the basement room. And so if you're looking at your PHPP and you just have a single overheating factor, it's really not telling you anything. And so I think that kind of more detailed analysis with regard to overheating is critical. I don't know what it's like in FIA, so you guys can tell me if it's more sophisticated. But the main thing we've also been doing is adding supplemental filtration. So we've been adding these filter boxes onto our manifolds where during the smoke season, you can put in these expensive HEPA filters, HEPA grade filters that'll actually take out the smoke particulates. So most of the year, you're just running your usual HRV dust filters. But then during smoke season, you can put these other ones in, and they need to be big enough that they don't cause too much pressure drop on and burn out your HRV. So the big manifold with these HEPA grade filters, we're really trying to make standard as part of our process because that air quality is absolutely critical. So what's next for us? Now we're trying to figure out how do we blend all of these things, throwing a whole bunch of ideas. How do we start to make that into something coherent? We're also in Vancouver where we're getting a density bonus for either passive house or net zero. We're going back and forth working with these different certification systems, and they each have their pros and cons. I'm showing a rendering here. On the right is our 13-inch net zero assembly. On the left is our 17-inch passive house assembly. So one of the trade-offs we have is square footage. With passive house, I'm losing 4 inches all the way around. At $1,500 a square foot sale price in Vancouver, that adds up to quite a lot of money in lost real estate. So we're always looking at that. Sometimes with net zero, it's easier on east-west sites because the sun can hit the roof. And sometimes with net zero, it's just frankly easier because I can just throw any old building together, go to energy modeling, you throw enough solar panels on the roof and away you go. Net zero is a suburban rating system. It doesn't tell you you've got a quality building because you can just throw a whole bunch of solar panels at a crappy building. And we're seeing that in some cases in Vancouver. But it is still progress on the status quo. And I think there's a lot of places where it can still be a great system. What we are wrestling with is in the city of Vancouver now, we can do multiplexes. So this is a triplex. It's a duplex in front with a laneway building at the rear, a north-south oriented lot. So we actually have in our initial scheme, we had 3 different certification systems on one lot, which is stupid, but anyway, we've got a south-facing duplex unit which gets the sun and easily meets Passive House Classic. The exact same building facing north, instead of 15 kilowatts is 30, doesn't meet Passive House Classic. It meets the Passive House Low Energy building. And then at the lane, because of the form factor and the solar gains and whatever else, it's not really going to meet Passive House either. And so we're doing net zero because it's got great roof access for all the solar. So you got 3 different systems. And each system is kind of tailored to its sort of specific niche. But it's a lot of different documentation. So just in the last month, we've started talking to the city of Vancouver about doing something different, which is to get rid of all of these and go instead to a combined system where we are doing passive house low energy building with an embodied carbon target. So in this case, EC 130. So we are letting the foot off the gas just a little bit on insulation and air tightness. We're going from 15 kilowatt hours to 30. We're going from 0.6 air changes to 1. But we are bringing in a lot of work on the embodied carbon side. And what it looks like is that the net climate impact is actually quite a bit better. That's still to be determined, but we're kind of working on that hypothesis. From our point of view, we would like to have a system that we can use on every single site and every single project. So I don't want something that only works when you're facing south. I also want to really bring those materials in. So this is how we try to bring it together. We're adding density into a walkable neighborhood. We're balancing operational and embodied carbon. We're doing an all-electric building, 0 fossil fuels. We've taken away an old gas-fired house. We've gotten rid of that gas line, got rid of the boiler. We're going to hopefully do deconstruction to reclaim that wood and trees that are on site. And we're adding the filtration and the extra features to make this house resilient. So in my mind, this is the kind of package of things that we are working toward that we want to kind of make standard for our work, and hopefully that we can expand on that. I think I'm going to wrap it up there. But I think this is part of the interesting discussion is whether all of these new ideas that we're trying to come in, does it change anything about our core sort of belief in Passive House and its metrics, or is there something new that has to come out of this conversation? And I don't know the answer for sure yet, but this is what we're thinking. So thanks for having me.
Thank you so much, Bryn, for that very inspiring presentation. Kim put in an order of questions, but Robert, I see that you have a number of questions. So I'm going to let Stephen and Marcus go first, if you're okay with that, and have you ask all of your questions together. I see you nodding. Fantastic. So Stephen Stone, are you still here? If you are, please feel free to unmute and ask your question. Otherwise, I can ask your question for you.
Yeah, I was just curious about when you're reclaiming the wood from older projects, what you do with the contaminants. I'm specifically thinking about lead, but also all the other goopy, nasty stuff that we've used in the building industry in the past. And if you could touch on that, it'd be great. Thanks.
Yeah, I mean, we work with deconstruction contractors, but the first thing we do is abatement. So there's a whole process of going in. Our main concern is with asbestos, at least on the house that we're working on. So they have to go in and strip it all out, and they have to do it to the renovation standard, which means that it has to be all be clean and vacuumed to the point that it's safe. If there was anything goopy or otherwise, I assume that would not be easily taken out. But most of the houses that we take apart are actually, the framing structure is quite clean. Once you get in there and pull out the bad insulation and whatever else, and you run that 2x12 through a planer, you get really beautiful fine grained old growth wood that comes out the other end. But I don't really have a lot of details there because it's not the piece that I'm kind of in there up to my knees.
Great, thank you. I'm switching around a little. So Marcus, if you're here, please unmute and ask your question.
Yeah, good morning. Bryn, thanks so much for your presentation. I know it was not so much focused on the nuts and bolts, the technical aspects, but one of the questions I have is whether you ran any high growth thermal analysis, and maybe this is not the first time you've used that wall assembly, but with a thick cavity filled with fluff and nothing on the exterior, the concern about condensation on the inside face of your sheathing. Is that anything you looked at, and kind of what gives you confidence that that's going to perform long term?
Yeah, I mean that's always a concern. I think I knew that this question would come up because anytime you put cold sheathing on in a passive house presentation, it's going to come up. We do a ventilated rain screen. We do a 1/2 inch plywood, which is a variable vapor open material. We're doing a vapor barrier paint on the inside, and in combination with HRV, we've felt like the condensation risk was minimized relative to keeping the risk from air movement and moisture movement through bulk water movement. We've always been of the opinion that bulk water movement and air movement is 100 times more impactful than diffusion. I know that a lot of folks put a lot of effort into keeping their sheathing warm. Their strapping and other kind of pieces are often still hanging out there. For us, we feel like the balance of risk gives us something that we can do cost competitively. We can use concrete as an architectural element. We can also hang structural elements on the outside of that wall without having things penetrating in all sorts of ways through that exterior insulation. So over the years, we've done everything. We've done exterior mineral wool, we've done ICFs, we've done SIPs, we've done uh, various blocks of anyway, we've done all sorts of things. So on this job, we were interested in using a double stud because we were curious if it could work in combination with cellulose to do a very low embodied carbon assembly. And in Vancouver, where they've taken buildings apart, they've found that they've generally been doing pretty well where they've used plywood as the exterior sheathing because of its vapor openness. But I gather that not everybody's going to be comfortable with that approach.
Great.
Thanks so much.
Before we move on, I just want to kind of acknowledge that we're at the top of the hour. So if you have to hop off, we completely understand. Again, we really hope to see you all tomorrow at the Reimagine Building Conference. But the rest of us can stick around till about 1:15. So we are going to go through the rest of the questions that were asked. So Robert, I think you had 3 questions. So why don't you just ask all of them?
Yeah, I'll summarize the questions 2 parts. One, we're by the ocean here in Santa Barbara, and we're finding elevated levels inside the house of humidity, 60+% sometimes, a little bit higher. And I was wondering what techniques have you used to lower humidity in the Vancouver area? And then second, if you could briefly touch on value, home value, and the high level of both beautiful design with energy efficiency. Are you finding that you're getting more value per square foot on the sales side as a result of your design and energy passive house design?
Yeah, I guess I would say that we do an HRV on every single project, and it does a good job of managing some of those humidity issues. And then beyond that, we'd have to be, if you needed active dehumidification, you'd have to go to your mini split or something like that. There are some HRVs that have heat pumps built into them that will do that kind of on an automated basis. But we've generally found that having a well ventilated house with solar gains that are balanced does quite a good job of just managing that humidity in its own right. Even in the rainforest, I've got a couple of cabins built in the rainforest. I put a little Zender 70 mini HRV, and it rarely goes above 60, even in that very, very humid, environment. So I think just following the passive house design strategies really gets you a lot of the way there. And then beyond that, I guess you could do, technical dehumidification. As far as design, I think there is a value premium for good design. Our projects are mostly built to suit, so we're mostly designing a building for existing owners. Every once in a while, we will do, say, a duplex or something where there are units being sold or rented. We find that they all sell or rent before even going to market because they're just people that are following us on social media. And so our clients have never had to spend any time on listings. So I'd like to think that there is a value included there. From the city point of view, if they give us a density bonus for passive house, I tell clients, you've got $1 million house, the upgrade to passive house is probably 100K. It's like 5 to 8% on hard costs. But you're getting an extra, say, 500 to 800 square feet at $1,500 a square foot. That's about $1 million in value. So you're getting $1 million in value for 100K investment. And so that's a pretty compelling ROI in terms of going to the certification. And so I think that certainly if we didn't have that density bonusing system, we would have much fewer projects that are actually going all the way through that full certification. So I think I definitely always encourage cities if they can leverage zoning in that way. It doesn't cost them anything, but they can have a pretty big impact.
Robert, did you kind of summarize all your questions?
Yeah, I'm all set. Thank
You're
you
all
so
set.
much. And Bryn, great presentation. That was wonderful.
Thanks.
So I have a bunch of questions, but honestly, I have no problem going last because I can see a lot that more questions are coming through, and I want to make sure that everyone has time to speak because I always have. So let's see, where did I put this? I had to move rooms unexpectedly. So Richard, are you still here? Don't.
Yes, I'm here. Sorry.
Oh, okay. Go ahead. Do you want to ask your question?
Yeah, sure. Thanks. I wondered whether that mounting facility in the PHPP would be sufficient for your room by room analysis that you carried out that you mentioned in your presentation.
Yeah, you can definitely dig into it that way. And I think that I think it's just important that we start looking at that. I think in the past, at least speaking for ourselves, when we went to certify, we were just looking at that summary total at the end that says, do you have that overheating risk or not? And you're like, okay, well, it kind of makes it work. But now we're realizing that it's actually the level of sophistication with which we have to engage with that overheating is much higher. And so there are a good suite of tools there that we can work with. I think it's just a matter of, whether we're shining our focus on that.
That element, yeah. Does that the bonusing system extend to other jurisdictions like the Sunshine Coast or somewhere like that up there? Do you know?
No, it doesn't. Unfortunately, it's just City of Vancouver. We have a very weird situation where the City of Vancouver has what they call its own charter, which means that it can have its own building code and it can have its own systems different from what the other cities in the province are allowed to do. So we have worked with a lot of neighboring cities, and they sometimes will get relaxations on height because you got thicker roofs. Sometimes you can get a little bit of extra square footage. They'll put like 2% or something basically to account for that wall thickness.
Right, on the
And I
building
think
line.
yeah, because 15 years ago, we built the first laneway house in the city of Vancouver, and we did that with a prefab 13-inch thick wall and triple glazed windows. The house was only 700 square feet. And so that wall thickness took, a solid percentage of our usable floor area because the city of Vancouver counted floor area to the outside of the cladding. And so there was this really perverse incentive against super insulated walls because it was counting as floor area. So at that time, we negotiated the first thick wall exclusion, which basically said, if your code minimum wall is this thick, then you don't have to count the extra wall thickness beyond what that code minimum wall would have been. And that was a very critical first barrier to green building, because where we are now, they're giving us incentives. At that time, it was about removing barriers. So FSR, height restrictions, these things are very substantial barriers that I'm sure you've all faced. And your city planners can do a lot to make those go away.
That's great news. Thank you.
Great, thank you. I'm still here, but my laptop changed rooms. I don't have a dock anyway. So anyway, I'm going to read Thomas's question for him. His question is, what metrics do you use to verify net zero energy? Obviously, PER is used for PHI, but interested in if you use different values like primary energy, final energy, etc.
For net zero, we're using a program called Hot 2000. Which is for many years has been the kind of default energy modeling that the city has required. And so they are looking at all of these various things and adding it up and giving us a number at the end. And to be honest, I don't think they have the same PER type setup that PHPP does. So I would have to defer to somebody who is an expert in Hot 2000. They're just looking at the straight up consumption. One of my critiques is also that some net zero projects are allowed to use gas. So if you're using gas as a boiler for the hot water, then your residual electricity is then covered by the solar panels, which just seems like a stupid way to do things. But anyway, yeah, I am not the guy to go for that answer. But you can look up the Hot 2000 model. That's what we use.
Great. There's some chatter between Ed and Thomas about kind of like different modeling software. I don't know, Ed, did you want to unmute and say anything specific? Might be just interesting, Bryn, for you to see. I'm gonna say no. Prescott. Oh yeah,
yeah, just a quick one. I was curious if you're using whole home dehumidifiers in Vancouver, because even though it's not typically hot like in the American South, it's pretty humid.
No, we don't. Like I said, generally between solar gains and heat recovery ventilation, we were able to stay within a very comfortable zone. And then, yeah, it's not an issue that we've struggled with. Maybe that'll change as the climate changes. But I think now that we're putting mini splits in, there is the potential to do dehumidification in a way that we didn't have before we were putting mini splits in every project.
Okay, interesting. That's all. Thanks.
Thanks, Prescott. Okay, so I think I'm finally up. So I had a couple of questions. You had mentioned that you provided documentation for the guys on site, and so I was just curious, what kind of documentation did you provide? Did you provide like your model? Did you provide like those little vignettes showing step by step?
Yeah, so the model we just exported it into a PDF, and the step by step is annotated. So we can just send the PDF, or we can take a screen grab and drop it in the WhatsApp chat, or if they call and say like, what are we doing? You'd say like, here it is. So I think there's the two benefits are figuring it out for yourself and then being able to communicate it. Because I think it's some architects, we start drawing things and we put all the different bits into a drawing. But you don't ever think about what the sequence is of how that actually has to go together. And I think one of the advantages, I guess, of being a design build is I'll draw something and I'll show the site guys, and they'll be like, "That's stupid." They'll say, "We're not going to do it that way. We're going to do it like this." And I'm like, "Okay." And so we have this kind of feedback back and forth between the assemblies and the guys on site. And I think that sequential 3D modeling really helps in that.
Did we lose Shefali? I think maybe Shefali's connection got lost there. That appears to be the case.
Yeah, I think so. It looks like we're at the end of the questions, though, so it was the
It
timing
looks
for
like
her
it.
to jump off.
Yeah. I know that she was switching machines and moving around. Well, Bryn, this has been really tremendous, and really appreciate the thought leadership that you're bringing to whole life carbon of buildings and how to navigate these, our new understandings essentially, and the evolving understandings of what the biggest impacts are around carbon. Here's Shefali, so that I'll defer to her to say any final words, but I just want to express my gratitude for you coming here and sharing your wisdom and your brilliance again. It's really been wonderful.
Yeah, thanks for having me.
Yeah, absolutely. So Shefali, if you are back and you want to,
I'm back.
Yeah.
I'm so sorry.
Don't worry.
I don't know why.
Worry.
I'm having a bad day today.
Yeah.
So did my question go through, or did it cut off middle, or my question was based. Oh, go ahead.
Oh, I was just saying it was cut off, I think.
Okay. My question was basically like, what kind of documentation did you said you had provided documentation for the people actually doing the work. And so I was just curious what kind of documentation.
Oh, yeah. Yeah, I was just saying that we would typically with a PDF or with images, and those kind of animations, we can send them the PDF, or we can just take screen grabs and drop them into a chat. And it's easy to communicate that way.
Okay. And then you had mentioned that you get a zoning bonus for doing passive house or net zero. Is that a prescriptive thing where it says you have to do passive house like FIAS or PHI or net zero, or is it a performance-based standard?
You have to certify under one of those standards. So it'd be PHI passive house. So we're always doing it under the European standard, which means we're often specifying European windows because their European glass measurements are different than North American glass measurements. And so, or we're doing CHBA net zero. You could also do living building challenge, but it's mostly either passive house or net zero. And increasingly, we're seeing a lot more net zero because it's just a lot easier.
Right, because as you've said multiple times, you could still do gas and just throw solar panels on your roof. It doesn't really require.
We have a separate in Vancouver. We have a separate ban on gas, so they do need to be all electric. But I have been approached by builders who they're trying to get the density bonus, and they've done this kind of crappy building, and they've got 30 solar panels on a roof when they really should only need 20 because they're building so crappy. And they want us to like help them get across the finish line. And I'm like, well, we could do that, but it's not really the business I want to be in.
I agree with that. Yeah.
So net zero, I mean, it's a suburban standard. It does a lot of good things, but it is a suburban standard. Whereas in the city, when you go to higher density, but your roof stays the same size, it gets really hard. So we find we're filling up the roof with solar panels, and then we're putting some solar panels on the carport. But once you go beyond, say, a fourplex, you start to run out of space for those solar panels. Whereas passive house, by contrast, actually gets easier in some ways when you go to a multifamily building. Your heating demand, your heating load is easier than when you have a really articulated, single family house. So each tool has its kind of place. Passive house is really hard on east-west lots with a big house to the south. Whereas net zero is great because you put all the sun on the roof and away you go. So I think it's just been interesting dealing with both of these systems and sort of seeing where each one shines based off the site.
Yeah, I agree. And that, okay, my last question is that you had mentioned that the city of Vancouver uses the beam calculator. So is there a requirement to like file embodied carbon calculations with your building applications?
Not yet, but they are looking at going toward that direction. In the first, so there's a few things. There's for the last year or two, there's been an incentive program where they've actually been giving early adopters like us some money to do the beam calculations and then make the upgrades on site. So the money, you can spend it where you want, but some of it goes towards modeling, some of it goes towards capital upgrades. And we've been doing this modeling through that incentive program. Now we are doing it as part of this density bonusing program. We're the first one to work with them doing that. And then in the next year or so, they're going to bring in embodied carbon reporting standards. And then eventually, I think there will probably be some kind of requirement, but that's kind of a few years down. So, starting off with the incentives and then the density incentives, reporting, and then requirements.
Yeah, I want to just echo something. You've had a lot of great one-liners in today's presentation, and I think we're all going to steal them from you. If you see the chat later, you'll kind of see people pointing them out, but I think the latest one that Zach just put in there is that net zero is a suburban standard is also a great line. If we have time for one more question, I see one here. I'm just going to read it just because it's 1:16. Bryn, do you find that you're drawing more fine detail drawings than for previous standard or traditional construction standards?
When we were figuring things out, yes. And there was a period of time from say 2017 to 2020 where we were doing a lot of detail drawings, I have so many different wall assembly drawings, so many different things of this or that. We were kind of going into the deep dive trying to figure out what our secret sauce was going to be in terms of something that we could do repeatedly. At the same time, we're doing these psi value calculations. At one point, we started arguing, trying to figure out what the psi value was for an extra peephole going through the front door. And at that point, I was like, okay, we're at the point of diminishing returns here. Like there's this passive house detail obsessiveness, and then there's going too far. And sometimes I show up on site and the clients are like, it's humid. I'm like, did you ever change your filters? They're like, filters? And we go and we like pull out this filter that's been there for 3 years and is just caked. And so I think that our detail obsessiveness sometimes has to be balanced against this idea of the messiness of the real world and the point that there are some diminishing returns. And that's what we're trying to figure out now after a decade of doing this is what's the right balance.